Welcome to Crayola Creativity Week. Today's theme is Endless Possibilities. We're here at Johnson Space Center in Houston, Texas in the USA with engineers, trainers, and specialists who work on virtual reality, spacewalks, and mission control in this incredible facility.
Hello.
Hi, Diana.
Hello.
And later, former NASA intern and illustrator Shane Tolentino will lead us in some fun art experiences. I'm over the moon with excitement about our conversations today. We'll be talking about how creativity is involved in every aspect of space missions. We are going to start at the Gateway Halo Module Training Model Factory and meet Brett Willman. Please introduce yourself and tell us about the project you work on.
My name is Brett Willman, and I am a NASA Gateway engineer working to bring the first space station to lunar orbit.
Please tell us about the Gateway Halo module.
Gateway is the first space station that is going to orbit the moon. Halo is the habitation and logistics outpost, which is one element of a multi-element Gateway program. Along with Halo is the power propulsion element, the international habitation element, and the European refueling module. All of these comprise the Gateway and will build up to a full lunar system for the crew to live on as they go and land on the moon.
Brett, please tell us about the creative collaboration work involved on the Halo module.
So that's what's wonderful about the Gateway program, is that we get to work with teams all across the world. We work with the European Space Agency, we work with the Canadian Space Agency, the JAXA Space Agency, and there are other entities that are going to be joining the program too. And so we daily communicate with each other in order to make this program successful.
Brett, this project looks complex. How has creativity helped you with problem solving?
What we're trying to do is use creativity and innovation in order to go to the next edge. We want to explore the next boundary. So that's why we're going to the moon and building all of these innovative systems with creative people across the world. And so once we get to the moon, we can start pushing the boundaries and maybe get to Mars. And now I think you should head over to see Angelica and the VR training lab.
Angelica, please introduce yourself and tell us about your job at NASA.
Hi, my name is Angelica Garcia. I am a simulation and software lead here at the Virtual Reality Lab at NASA Johnson Space Center, where I help develop, maintain, and deploy simulation systems for astronaut training.
Angelica, growing up, did you imagine yourself working in a job like this?
So when I was little, I was actually born in Ecuador. I lived there until around 8 years old, and then we moved to the States. One of the places that we moved to was Orlando, Florida, and I got to experience shuttle launches and landings, which was super cool, and I got to hear the sonic booms, and I knew that I really enjoyed science, I loved technology, but I also really loved art. So I wanted to be an artist, but also tie all of that in. So I went and did aerospace engineering for school. I got the opportunity to work with virtual reality at Langley Space Center in Virginia, and I ended up here.
Angelica, please describe how virtual reality is being used to train astronauts.
So we actually use virtual reality here at Johnson Space Center to train crew members to practice different systems. One of my favorites is SAFER, which is a jetpack that they wear for emergencies whenever they come out and do a spacewalk. So this system, you can actually put a headset on, and once they have the headset on, they can see the entire International Space Station. And there they can practice how to fly themselves back to station. So one of the biggest challenges that astronauts have faced with virtual reality is being able to train not just here in Earth, but also being able to train in the International Space Station. Virtual reality is a technology that requires very powerful computers, which we don't necessarily have in space. So what our team has done is developed a virtual reality solution so that astronauts can not only train here on Earth, but also be able to use a headset in space. So we've talked about how we use virtual reality for spacewalks at the International Space Station, also here on Earth. But what do astronauts do inside of the space station? Also, how do they exercise? How about we go check out what Kimberly's doing over in the exercise lab?
Kimberly, please introduce yourself and tell us what you do at NASA.
My name is Kimberly Jadwick, and I am a Medical Operations Countermeasure System Instructor here at NASA.
Kimberly, please describe the exercise lab and what happens here.
This is the Countermeasures Exercise Lab, where the crew come in and they're trained on how to exercise on the Cevis bicycle, and then we have a treadmill and a weightlifting machine in space. And we also train them on how to do maintenance to keep these exercise devices working.
Kimberly, how does the International Space Station's microgravity affect astronauts' need to exercise?
That's an excellent question, Diana. In space, they tend to lose muscle and bone density when they're floating in microgravity, and so we have them exercise every day, whether they're cycling or running or weightlifting.
Kimberly, how did your passion for education and your creativity lead you to this cool job at NASA?
I've always had a passion for teaching, so before I came here I taught elementary school, and I had a chance to participate in a Jason Expedition to Mars teaching event. That allowed me to come back to my classroom with a whole bunch of activities that were fun, where we would research and use our reading skills to learn about space, and then during our math time we would go analyze results from rockets that we had designed during our science class. And then we ended all that by talking to astronauts who were down in Florida underwater working in the NEMO environment. And shortly after that, I heard that they were looking for instructors to come train astronauts at NASA, and here I am. So now you know how and why the crew exercise in space, and next Jessica's going to tell you how crew live in space.
Now we are in the Space Vehicle Mock-Up Facility. We are meeting with Jessica Voss. Jessica, please introduce yourself and tell us about your job.
My name is Jessica Voss, and I'm an aerospace engineer here at NASA's Johnson Space Center. I'm currently the Crew Systems Integration Lead for the Orion spacecraft. And in this role, it's my job to design, build, test, and operate everything that the crew is going to need to execute the mission to the moon.
Jessica, as a kid, did you have any idea that you would grow up to be a NASA spacecraft systems engineer?
When I was growing up in Alaska, I knew that I absolutely loved looking at the stars and the planets. I grew up with a big, huge telescope in my garage that my dad would take me outside, and we would look at Saturn's rings and some of the constellations. And that definitely inspired me to want to do something in space.
Jessica, what does it mean to stay human-focused on large-scale spacecraft projects?
I'm so glad you asked this question, because there are a couple of things that we in particular really care about when it comes to designing the vehicle systems and the spacesuit systems. The first one that we really pay a lot of attention to is the human systems interface. So making sure that the crew is able to access and operate all of the things that they need to do to make sure that they remain safe and healthy throughout the mission. This can be everything from being able to don and doff their own suits, to commanding the spacecraft through the displays, to responding to any sort of an emergency event, whether that's on orbit, so meaning like during the mission while they're in space, or even post-landing after they've returned to the Earth.
Jessica, what questions do kids often ask you about life on board a spacecraft like this?
So they absolutely focus on many of the same things that we do here on Earth, like eating and exercising and sleeping. And the interior of the Orion spacecraft is completely reconfigurable to allow for all of those things to happen for all 4 crew members. The first thing that we make sure that the crew is going to be able to do is have a meal all together, for the most part, all at the same time. And we do that by providing a water dispenser for their rehydratable food items. So items like this one, where this doesn't look all that palatable right here the way it is today, but this is how we pack it, dehydrated, and then the crew on orbit can attach it to the water dispenser and then put it into the food warmer, and it turns magically into a yummy oatmeal, raisins, and spice meal for breakfast. The other option they have is just using the food warmer, and they can heat up specific items, different desserts, or basically pre-made meals in a package that it acts like a can. So if you go to your pantry and you pull out a can of any sort of type of pre-made meal or soup, we have something very similar, but it's packaged flat so that it's easier to pack and easier to put into the food warmer to be heated up.
We are now going to learn about spacesuits and spacewalks from Alyssa Battacletti. Alyssa, please introduce yourself and tell us about your job.
My name is Alyssa Battacletti-Nofke, and I work as a spacewalk trainer and flight controller. So specifically, I work on the International Space Station, or the ISS, where we use this suit, the Extravehicular Mobility Unit, or EMU, to perform spacewalks. So spacewalks, the fancy name for that is extravehicular activity, but it means any time that we go outside of the space station to fix something, install something, repairs, upgrades to make the space station function. We use this suit to do that. So my job is to teach the astronauts how to do spacewalking, and then sit in mission control to help them actually execute the spacewalk in space when they're doing it.
Allie, when did you know you wanted to work for NASA?
So when I was little, my father taught me all about NASA and space travel. He was a young boy when we were going to the moon with the Apollo program in the 1960s. He told me all about that, and I just thought, that's the coolest thing ever, to send humans to space. I want to be involved in that. So I was probably 7 or 8 years old, second grade, and I decided I wanted to work for NASA in human spaceflight. Luckily, I also, as I grew up, went through school. I loved all my math and science and technology, computer classes, so that jived really well. I went and got an aerospace engineering degree at Purdue University that led me to this job. You know, there's a lot of creative outlets that I think play back into my creativity here. I'm also a very passionate choral singer. I love to sing in choirs. So I kind of take my artistic, creative side with music, and then my technical expertise side with all the STEM education I have, and blend all that together to make me who I am.
Allie, please explain why you're known as the Professor of Spacewalks.
So I teach a lot of classes about spacewalking, and I've kind of started calling myself a professor of spacewalks. So I specifically teach all about this spacesuit and all about spacewalking.
Allie, why is it important to blend your technical expertise with creative problem-solving skills?
One thing I think is really important, as an engineer, you're always going to be working on teams. You're never going to be just by yourself alone at your desk. You're always going to be integrating with other people, and as such, you need to be able to communicate, to speak, to write. Very important. I think my experience outside of NASA, especially in choir, and that kind of leadership environment has really helped me with my social skills and my communication skills, to then be able to take that back to NASA and use all that here to integrate technically. I have so enjoyed my time with my career here at NASA. A big part of that has been working in mission control during spacewalks, and I think you should head over there next.
We are now at the Mission Control Center's control room and talking with Zeb Scoville. Please introduce yourself and tell us about the work you do.
Hi Diana, my name is Zeb Scoville. I'm a NASA flight director at Johnson Space Center in Houston, Texas. And behind me in this room is Mission Control, where we are flying the International Space Station at 17,500 miles an hour at about 250 miles above Earth. The people in this room behind me are watching all of the systems and the computers and the crew and all of the things that keep the astronauts safe, keep the space station flying, and everyone has their own little specialty. So as a flight director, I get the privilege of leading this team to accomplish amazing missions, to explore space, to solve science, and make life better for everyone here on Earth.
Zeb, please tell us about this control room.
This control room is a hub of the operations for the International Space Station. We're located in Houston, but we have partner control centers all around the world, bringing in the cooperation of flight controllers and scientists and engineers from Europe and Japan and Canada, and 15 partner nations have collaborated to make this a project that humanity can be proud of, solving problems on the Earth in space. We look at the systems on the space station, every little computer and sensor and regulator and valve and engine and window and science facility has systems monitoring it to make sure that they're functioning properly. These controllers behind me use the computers to look at those systems and make sure that they're not broken, making sure that they're operating correctly, and when they see a problem, they're ready to respond.
Zeb, describe the collaboration involved in monitoring a mission.
When we build the space station, we need parts built in Japan to connect to parts built in the United States, which then connect to parts built by different companies like SpaceX and Northrop Grumman and other countries around the world. In some cases, all of these pieces have never come together before until they've met up in orbit, traveling 17,500 miles an hour. You don't want to find mistakes when that happens, but sometimes we have to be ready to respond. Doing so requires collaboration, cooperation, and teamwork. A lot of people think that the astronauts are flying the spaceship. Really, the flight controllers and flight directors in rooms like this behind me are the ones that are actually flying and controlling the spaceship. The astronauts are kept busy with spacewalks, science experiments, health and exercise, and all of the work that it takes to maintain and fix hardware that's been up in orbit for over 23 years.
Zeb, are there challenges you face in mission control that require creative problem solving?
Once a mission launches to the International Space Station, it's there, and if anything breaks, there's no running to the hardware store to get a spare part. We have to solve problems with what we have on hand. In some cases, that means inventing tools or solutions to problems which we may not have thought of in the past. I remember a time many years ago when one of our solar arrays was damaged by a piece of debris. Within the course of a week, we had to invent a way to put a crew member out on the end of a long robotic arm and used some wire and pieces of plastic to actually sew the solar array back together again.
Now that you've heard about the preparation involved in going to space, several NASA astronauts would like to share what's next through a reading of the book You Are Going.
Hi, I'm NASA astronaut Victor Glover.
My name is Shannon Walker, and I am a NASA astronaut.
My name is Soichi Noguchi, Japanese astronaut.
Hi everyone, I'm Colonel Mike Hopkins, NASA astronaut, and I just recently returned from the International Space Station as part of the Crew 1 mission. And today's pretty special because I'm going to read a book to you called You're Going, a story about Artemis, and it was illustrated by NASA Orion intern Shane Tolentino. So let's get started.
When you look up at the night sky, what do you see? On a clear night, you can see thousands of stars. You might even see some faraway planets. The object that most likely to catch your eye is our neighbor, the moon. Right now, the moon seems pretty empty. But soon, NASA's Artemis astronaut will land on the moon for the first time since the Apollo missions over 50 years ago.
It's a great picture of story time, just like we're doing. Going to the moon takes the talents of many people working together. People at NASA work with partners all across the United States and even other countries. Artemis is all about teamwork. And you can see a part of that team right now working on Orion. Looks like it's in a clean room there.
Astronauts will ride inside the Orion spacecraft on their trips to the moon. We always name our spacecraft, and the one going to the moon is called Orion. You might be wondering how Orion gets into space. Well,
The Space Launch System is the rocket that will launch Orion into space. You can call it SLS for short. SLS is the most powerful rocket in the world. It's taller than the Statue of Liberty, and its thrust or force is as powerful as 160,000 race car engines. That is a lot of engines. And here you can see, that's the SLS right there. It looks pretty big to me too.
Our first Artemis mission will send Orion into space without astronauts to make sure everything is safe. Later, Artemis mission will take astronauts to the moon's surface. These astronauts will get to walk on the moon.
how exciting. I would love to walk on the moon. As our astronauts travel to the moon, we will be here to cheer them on from the ground. When Orion is launched into space, The powerful SLS rocket will help the spacecraft to reach a speed of about 25,000 miles per hour. Whew, that's fast. That is 50 times faster than an airplane. SLS will zoom past the highest clouds. And here we have a picture of people on the ground cheering on after Artemis has launched into space.
Astronauts train for many years to prepare for this moment. They work hard for the chance to be a space explorer. Astronauts must learn about many things like meteorology, the science of weather, and engineering, the science of machines. They also learn how to fly a spacecraft. It's not an easy job, but it's worth it to learn about our universe. And there you see a picture of astronauts who have obviously done all that training piloting a spacecraft.
Oh, and they lost their sandwich too. You see that? That's making me hungry. Now, Artemis astronauts will not go to the moon alone. When they fly, they take the whole world's hopes and dreams for the future of space exploration with them. We are going together.
With Artemis, the first woman and the first person of color will step on the moon. The whole world will be watching and ready to celebrate.
What a great opportunity, and I look forward to when it becomes real. The first Artemis astronauts will pave the way for humans to stay longer on the moon. Imagine each night standing on the moon and looking up at the Earth. What a great thought. Astronauts looking up in the night sky at Earth.
Artemis astronauts will work on and around the moon. NASA and its partners will build a spaceship to orbit the moon. It will be called the Gateway. And if you look right there, that's the Orion capsule. So that's what they launched on, and it docked to Gateway right here.
In the future, we will build a base camp with rovers, a home, and a laboratory. What do you think astronauts do on the moon?
And of course you gotta eat. So we're gonna look at ways to grow fresh fruits and vegetables on the moon also. Who knows what the future can hold for us? There is still so much we don't know. And here's some people on the moon growing those fruits and vegetables so they have something to eat.
Space exploration brings people together from all over the world. It gives us a chance to discover new things. It teaches us more about the universe and our little blue planet Earth. No matter who we are or where we come from, we all call this planet home. That's a pretty good drawing. I don't think I could draw that good.
We need imagination, creativity, and determination to take us farther than we have ever gone before. And NASA can't do it alone. Reminds me of when my kids built a spaceship out of all of our moving boxes. That was fun.
Will you be part of our next group of brave explorers, the Artemis generation?
And guess what? That's the end. So, You Are Going, a story about Artemis. Thanks for joining me today.
That was awesome! NASA really does need kids like us to bring our creativity and interests to future missions. We are the Artemis generation. Are you ready to create your endless possibilities? We are thrilled to be joined by the artist whose beautiful illustrations we saw in this story. Welcome, Shane Tolentino. Please introduce yourself and tell us about your NASA internship.
Hi, my name is Shane, and I'm an illustrator and graphic designer from Chicago. 2 years ago, I had the opportunity to become an illustration intern at NASA, where I got to draw spaceships, astronauts, and kids who love space. Before my internship, I had no idea that writers and artists also worked at NASA along with engineers and astronauts. When I was still in college and the pandemic had just started, I was talking to one of my favorite professors about different opportunities for the future in a time when we didn't know what the future would hold. He listened to me patiently, and afterwards he told me, "Shane, you could tell me you want to be an astronaut tomorrow, and I have no doubt you would find a way to do it." And then I thought, does NASA have an art department? I then submitted my application to be an intern and was matched with my mentor, and soon learned that yes, NASA actually has all kinds of artists working on lots of different projects.
Shane, please tell us when you fell in love with art and realized that you are an artist.
I've always had so many wonderful people in my life that encouraged me to draw. My parents and teachers were very supportive of my love for art from a very early age, and I would take the opportunity to draw on every surface that was available to me. I love drawing so much that if I had gone through a whole stack of printer paper, I would flip it over and get right back to drawing again just to fill the other side. I also learned that drawing was a way to think more deeply about what I could see in the world around me. I would draw my friends, the plants outside, or pictures of animals I saw in books. In school, it also helped me to think through problems and focus in class. I fell in love with art when I realized I could capture all kinds of things I love and care about in a drawing. Even if it was hard to put in words, I knew I could say it with art.
Shane, how did you learn the science facts you needed to know to create these illustrations?
My mentors at NASA helped make sure that I had up-to-date pictures of important things like spacesuits, the Orion spacecraft, and the SLS rocket. The other interns on my team would also offer me helpful tips from what they had learned in their projects that helped make my drawings better. And most importantly, for some of my art, we would all work as a team to imagine what the future of space exploration could look like.
Shane, your illustrations in You Are Going show how magnificent our moon is. Please draw a view of Earth as if you were standing on the moon.
Just draw one big arc from the left side of my page to the right. We want to see the curve of the moon as it appears to us. And then, over top of this curve, we're going to draw one little circle off in the distance. That's the Earth. And so, towards us, we can draw some big moon craters. I draw these as circles that got squished down a little bit. Just some ovals. And then I can draw some little lines to show texture, to show the craters kind of rising up out of the ground, and then adding some shadow on the inside of the craters to show that they go in a little bit too. And so the craters that are closest to us, we can add the most amount of texture. So the most amount of lines, the most amount of shadow, and the most amount of detail. And then, to give the illusion of other craters being a little bit farther away from us while we're standing on our magnificent moon, we just do the same thing, but we add a little bit less detail than we did before. So a few lines here and there. And the moon has lots of different craters. So feel free to add as many as you want. They can overlap, you can have craters inside of other craters, whatever you want. And then as we get further out, we start to add craters with less detail. Maybe they're just a flat oval and a handful of lines, or maybe they're just an oval. And maybe the ovals get smaller and smaller as we go out. And the ovals don't have to be perfect. They can also be half ovals, or they could even just be lines. When the craters are that far out, they don't have to have a ton of detail. So now that we've drawn these craters on our lovely moon, we get to color in the Earth. It's made up of green and blue. And it doesn't have to be perfect. It doesn't have to be exact. And now the fun part is we get to fill in the sky with lots of stars. And you can draw these stars however you want. You can draw a 5-pointed star. You can draw a 4-pointed star. You could even just draw them as circles. There are so many stars in our galaxy, in our night sky. So fill up the sky as much as you want. This also doesn't have to be perfect, and your stars can be of all different shapes and sizes. You can also make your stars whatever color you want, because stars also come in different colors too. And if you make a mistake, that's totally okay. There's so much out there. You just want to make sure the sky is full of bright twinkly stars surrounding our magnificent moon and our home planet Earth. And then you have a finished drawing of our moon and our Earth and the stars around it.
Shane, the book You Are Going points out that today's kids are the Artemis generation, and that NASA needs their creativity and imaginations to guide future space exploration. Please demonstrate how kids can draw a web that shows how today's interests can lead to future NASA careers.
Alright, so the first thing I'm going to do when drawing out my career web is think about what I'm interested in. And so to represent that, I'll just write my name in the middle of the web. And then just a small drawing of myself with a big old smile and big old glasses. And so I'm really into art. So from my name, writing the word art and putting that in a special kind of bubble. So instead of a normal circle, I'd like to draw a little icon around the word art to represent art. So I've drawn a little paint palette. Let's add some colors. And you can use whatever you'd like to draw this career web. You can use a crayon, a pencil, a pen, or a marker like I'm doing right now. And so an interest in art can lead to a career in graphic design at NASA. Graphic design. And graphic design is real important to NASA because graphic designers make lots of posters and informational graphics and things that the public sees. So an interest in art might also be related to an interest in drawing. I'll draw a little pencil around it. And it's okay if your icons are different than mine. And so if you have an interest in drawing, you can also be an artist. And so I'm not only just interested in art, I'm also interested in English, which I'll draw a little book to hold my interest in English. The book can be on a little bit of an angle. A little bookmark hanging out. So from my English book, I have an interest in journalism. So I'll write out the word journalism and put it in a big circle. And if you have an interest in journalism, you can be a journalist. It's easier to put your words in a circle if you write them out first and then draw a circle around it because you know exactly where your circle is going to go. And then also from an interest in English, I could have an interest in creative writing. And people who like creative writing could have a career at NASA because NASA also needs technical writers. And you can have all kinds of different interests, have as many bubbles branching out as you want. You don't have to pick 2 things, you don't have to pick 3 things or 4 things, you could have an interest in all of them. And all of these lead to a career at NASA. Just write down anything that you like. And so this is just a little part of my career bubble, but you could have all kinds of interests that could lead back to a career at NASA. You could be really into PE, social studies, math, performing arts, science. All kinds of interests can lead to a career at NASA. These are just a couple of mine.
Shane, thank you for demonstrating how kids can use their creativity to draw the Earth as it is seen from the magnificent moon, or plan their career aspirations using the Follow Your Dream map. We want to thank the NASA team and Shane for sharing their personal stories and inspirational ideas. And we thank all the kids who have joined us today from around the world. Parents and educators, be sure to check out more exciting learning ideas at Crayola.com/creativityweek. We'll be sharing an exciting new activity every day this week. Remember to share your kids' artwork on social media using #Crayola Creativity Week. We're sure it will be out of this world.